Good morning. Today we're going to talk about a new I/O simulation tool from Wonderware that allows us to see some live data. You know, we all know what a DA server is. This acts like a DA server, installs like a DA server, looks like a DA server, but in the end it's not truly going to connect to a PLC. We're going to choose some algorithms that we want to generate some data, whether it's a sine wave or a sawtooth. We can generate some toggle bits going on and off, and we can change the frequency and things like that. So it's a nice little tool to be able to test your systems, test your objects, test your tags, test your graphics, test data going your historian. So anything you can do with a real live process, we can simulate that with this tool and bring data in. So before you go to the field, you can actually test some data, have good confidence that at least from the I/O simulation perspective, back through the objects, tags, graphics, historian, that you have a good data flow and path is good before you get to the field. So in order to play with this tool, of course, we need to get it. So we can go to the Wonderware Tech Support site. We can go to the Product Hub. And once we're in the Product Hub, we can pick, say, the DAS Sim. That'll give me the link to the download. So if I click on this link, it'll let me download the DAS SIM tool. And then we can install it just like any other DA server on the system. So I have installed this DAS Sim on this machine in the interest of time. So now I'm going to go to the configuration of this. I go to System Management Console. I drill down into my Operations Integration Server, which may be new to some folks, which is the newer generation DA servers. You can see I have this DAS SIM running, and here's my configuration. I already have a few algorithms already defined, but basically I would create this new port, and then from this new port I can right click, I can say I want to add a new PLC test object, and then I choose the algorithm I like. If I want it to be a sine wave, cosine, sawtooth, a toggle, also have a triangular, a string, and a random number generator here. So I choose what algorithm I want. I have some of these already defined for you. So if I look at the sine wave, I have chosen sine wave. I can adjust some parameters here. The rate of change, percent change to affect the waveform. And of course, when I link this, I have to define a device group, and it's going to be called sine also. So when I'm doing my item naming and addressing from my objects or from InTouch, I'll use this as my topic or my device group to be able to access this data. There's the device items tab here. I don't need to put any in my device items if I truly pre-built those device items in my object level or my tag level, but if I want to have an alias lookup, I could have that here. I could put an alias name here, and it's going to point to another reference that I'm trying to reference in the DA server itself. So this DA server, this simulation server is running. If it was not, if this had a red box next to it, I would have to right click on it here and say activate the server. I'm going to deactivate it this time. You can see it's going to take it offline. It's got the red checkbox. If I want to activate it, go online. I say activate server. Now it's going to go online and start feeding some data to my data sources. So everything should be up and running at this point. So I'm going to use System Platform here, our object technology, to be able to test this simulation tool. So one of the first things I need to do is I may need to make an instance of the DD SuiteLink object, and then configure that DD SuiteLink object to point to this DAS Sim. So you can see server node, I'm on a local machine. I'm going to point it to this new server called DAS Sim. And of course, inside of here, I'm going to define the topics that will link that to the device groups that I have defined inside that DA server. So they're the topics I define, and this is how you're going to actually link between your object, point to the DD SuiteLink object, and it's going to pass that information down over to the DA server. So if I look at an object that I have here, this thing called sine wave, if I double click on this object, okay, it's got some parameters in here. I'm going to be interested in the feedback bit, .fb. I have I/O assignment checked, and I have history checked, so I want to historize this information. And I'm going to just put a trend high and a trend low there so I can see that on my trend when I get to it. The other thing I'm going to use here is I'm going to use the System Platform auto assignment capability. So basically I take this F-sign and I drag it over here to this I/O device group called sine wave. So that's going to link this object called F-sign1 to that device group called sign. If I click on that, you'll see what the auto assignment does for me. It's going to go through and it's going to assign it to DAS Sim. Sign is my device group, and this is my attribute name, fsign1, which is my object, and then the actual attribute called FB. So that's going to pass this information over to that DA server, and it's going to return me a good value. So let's test that. I can click this checkbox here, and it's going to give me a runtime value. You can see right now it's giving me a negative 8.76. I can do that again. You can see this data is going to be moving. It's going to refresh and give me a new type value here. So that's basically what you do. Is you could type these addresses in by hand if you want, but I'm using the auto assignment. The interesting thing about this is the actual name that I renamed it with fsign1. That means it's going to return a floating point. If I named it with a B, it's going to return a binary number. So the actual first name of the tag has to do with what type of value it's going to return, F being the floating point. So once I have some IO assignment pointing to the new DA server, I can go look at some data and see if I see some live information out there. So let me go to Object Viewer first and see if I see some good data. So I'm going to Object Viewer, and we'll drill down and make sure we have good quality data coming in from that simulation software here. So I'm drilling into fsign1. I'm going to go to my feedback bit. I'm going to add that to my watch list and should see some live data here, some things moving as the data is being fed from that IO simulation tool. So you can see I do have indeed live data here. So let's take a look at some of the data that we're generating in our trending tool. As we know, we're in an object. We basically check the box inside the object technology. It automatically pushes that information over to our Wonderware historian, which is a great feature. I don't need to go configure any tags in the historian. It's automatically done from the object. But I've checked this box as I want to look at this sine wave configuration object I have here. And you can see I have this sine wave on the screen. If I check on my sawtooth, you can see there's my sawtooth simulation object going on there. So all this data is coming from the new simulation tool, can be used in your development and testing of these different object technologies to be able to see some live data on your screen. So let's take a look at some of the live tuning parameters that I have. If I want to go through here and actually change some of the variables to see it affect my waveform, I go back into my system management console, and you can see I'm looking at this sine device group, if you will, and I can go here and change some of these parameters. If I go change, say, the rate of change of this, make this say 50% or 50 milliseconds, and I apply that, these changes become live. So you should see it affect the waveform here. You can see it should start, increasing that duty cycle. We're going to see this sine wave more often. Let's give it a minute to catch up, and we can be able to see the difference in a minute here. So you can see after a few cycles, you can see that the frequency is happening more often here. We'll make it to a higher number, and we can see this sine wave kind of slow down and flatten out a little bit as we increase that. So a couple of different tuning parameters, the rate of change, percent rate change there, something else we can do. But you can see what happens when I increase the rate of change here. So you can see after some time passed by here, we can see that this changing the rate of change affects the waveform. You can see we increased that rate of change, we decreased it, and you can tune how you want to see your simulation data. Hope you enjoyed watching. Please check us out on other videos on the Knowledge Center. Thanks again.
Need to learn more about this and other InSource products? Check out our training tracks designed to guide you down your learning path for InSource products. Whether you're using a classic InTouch and Historian architecture or using System Platform, we have a track to help you get the most out of your software investment. To register or learn more, click the link in the video description below. Thanks for watching this InSource video.